Hi all, year 12. Now, today we will have a lesson by watching the video. Sorry about that. What I can give you is that I give you a video for you, but I really want to have a live lesson with you all today, but unluckily we cannot. So, first of all, to make the revision of the first lesson, you know that when we are undergoing the section, the 9.4 and 9.5, we have five formulas there. Can you write down all these five formulas first? Before we start our lesson. Okay, now you can pause your reading and write down this formula. And after that, you can play the video again. Okay, now let us check the answer of these five formulas. For the first one, we know that we have V is equal to U plus AT. For the second one, we have S is equal to U plus V times T over 2. For the third one, we have V squared minus U squared is equal to 2AS. For the fourth one, we have S is equal to UT plus half AT squared. And for the fifth one, we have S is equal to VT minus half AT squared. You will notice that why do we need to have five formulas? First of all, because we have five unknowns there. They are U, which is the initial velocity. For V, which is final velocity. For A, that is the constant acceleration. For T, that is the time taken. And for S, that will be the displacement. So that you will notice that for the number one, we do not have any displacement. For number two, we do not have any acceleration. Number three, no time taken. Number four, no final velocity. And number five, no initial velocity. You will see that sometime in the question, data is missing. So we must make sure that you can choose the correct formula so that I can solve the questions easily and you will get the answer. And for number 6, you will see that for this time, section 9.5, most of the time we will learn some question that with gravity. So you must make sure that for the gravity, when you point downward, that will be negative 9.8 ms meter per square second. So today, I will have some discussion with 5 questions in exercise line with you. So first of all, let us look at the question. For exercise line, okay, question 1. A cliff diver jumps from a point 28 meters above the surface of the water. Modeling the diver as a particle moved freely under gravity with initial velocity is equal to 0. That means that for the first one, you know that this one is 0 meter per second. And then it jumps from the cliff to the water. Water here. Okay, now, and you know that from a point 28 meters, so that means this is the height of the cliff is 28 meters. Okay, now for part A, you are going to find the time taken for the diver to hit the water. For B, you are going to find the speed of the diver when he hits the water. Okay, now, so I will give you some time. Now, please pause the video and find out that what information are given. For example, you have U, V, A, S, T. So can you find something in this question? Okay, now, after you do this, please play the video again. Okay, now, thank you to coming back. So for part A, you will see that we have the time taken we need. So that means this one must be available here. So I must keep this one T here. Okay, let's look at the question. You will see the diver as a particle moving freely under gravity with initial velocity 0. That means that the initial velocity for you, that will be 0 ms minus 1. Okay, for this question, I have 28 meters. That means this one is the displacement. But please pay attention. First of all, I choose going upward to be positive. So this time I will choose this one will be negative 28 meters because it goes downwards. And also we know that this one is based on the gravity. So A this time is negative 9.8 meter per square second. Okay, now so we do not have V this time. No need for part A. So what can we do is that we're going to find T with UAS. So the formula we use this time is S is equal to UT plus half AT squared. So we will change them one by one. First of all, I will change U to 0 times T. That means, oh, obviously, this is negative 28 is equal to half times negative 9.8 T squared. So after the calculation of it, let's do the calculations. The answer of T is 2.39 seconds, make it 2.4 seconds to 1 dp. So this is part A. Okay, and for part B, once again, you will see U is equal to UVAST. I'm going to find the speed of the diver when he hits the water. That means we want to find V. This time we have 2.4 seconds for T. We have S is equal to negative 28 meter. With A is negative 9.8 meter per square second. And also even the U 0 meter per second. This time I'm going to find V, but I will suggest you that not to use T here. First of all, you have two reasons for this. Number one, because this one is calculated by us, so we are not sure in your examination, do I get it correct or not? So I will skip this one. I will use the other thing, except the information is not given. The information is not given by the others, so that so we will skip T here. So I will use UVAS to solve this problem. So the formula we choose this time is V squared minus U squared equal to 2AS. So that is V squared minus 0 squared, which is equal times 2 times negative 9.8 times negative 28. So we can find out the V is, by using the calculator, the answer of this one is 23.4 meter per second. So this is the answer of question 1. Okay, you can pause the video so then make sure that you can get all of the information and you can put something in notebook and you can know how to do it. Okay, now we will go to question 3. Okay, let's look at the question. This time, I only give you UVAST. Okay, before you go on to the video, now, first of all, please draw the diagram of this question 3. Second one, I want you to write down what information is given in these questions. Okay, now we are coming back. So let us draw the figure first. A ball is thrown vertically downward. A ball is thrown vertically downward. Okay? From the top of the tower. Okay, this one is the tower here. The tower. With the speed is 18 meters per second. So that means one at the very beginning is 18 meters per second. So that means I know that U is 18 meters per second. Okay, it reached the ground in 1.6 seconds. So the time here taken is 1.6 seconds. So that means time is 1.6 seconds. For every time, make sure that time is scalar. It's not a vector, so we do not have any direction of it. So we do not, most of the time we only have positive here. And find the height of the tower. That means I'm going to find out the displacement of the tower. In case the displacement and will be equal to the height of the tower. So the only thing that we have is always, obviously we have A here because A is negative 9.8 meters per second, per square second. So we did not have V this time. We have U, we have A, we have S, we have T. Once again, we have S is equal to UT plus half AT squared. And then we can write that now. For U, that is 18 times 1.6 plus half times negative 9.8 times 1.6 squared. So let us do that together. First of all, for 18 times 1.6, you got the answer of this one is 28.8. And then after that, I think that we have a minus here. So we have 1.6 squared times 9.8 and divided by 2. So you will see the answer of this one is 12. The U must be negative also, right? Yeah, the U must be also negative piece. Sorry about that. Because it go down, so we have the downward of it. This is negative 28 point. Sorry about that. Okay, we will go to 9.8. 9.8 times 2.56 over 2. So this is negative 12.544. So we will add back to 28.8. So you will see this is negative 41.344 meter. So that means the tower, the height of the tower is 41.3 meter. So this is the answer of the question 3. Okay, now we will go to question 5. If you cannot finish, just pause the video first. Okay. Now we will go to question 5. Once again, a ball is projected upward from a point which is 4 meters above the ground with speed 80 meters per second. Now A, find the speed of the ball when it's 50 meters above its point of projection. For part B, you're going to find the speed with which the ball hits the ground. Okay, now once again, please pay attention. You must do 2 diagrams. That means one for A and one for B. So now please pause your video and draw the diagram for A and draw the diagram for B. And then write down what is the information is given, UVAST for both questions. And now you can pause it. Okay, now we go to point A, part A. Now, first of all, we write down kick upwards as the positive direction. Make sure that we got correct one direction first. Okay, now a ball is projected upward from a point when 4 meters above the ground. So that means I have a ball, which is 4 meter height. And then I will project it upward. And the initial, you know that this is 18 meters per second. So we know that U is equal to 18 meters per second. After that, obviously, many times A is negative 9.8 meter per square second. Okay, now we are going to find the speed of the ball when it is 50 meters above the point of projection. So I'm sorry about that. Although this one above the point of projection, so this one is 50 meters. So this time for S is 50 meters. And then I'm going to find the speed of the ball. That means I'm going to find a V there. So I do not need T. So we have V, U, A, S. So I'm going to find out that this one is that V. square minus u square is equal to 2as. So that will be v squared minus 18 squared times equals to 2 times negative 9.8 times 15 meters. But this one, you will see this. The answer of this one is v is equal to square root 30, positive and negative. So this time is you have two answers, positive 5 and negative 5.5 meters per second. The reason why you have two answers is that, please pay attention, we need to keep both answers because after you throw them up continually, it may stop. And then it will go down again to another level with the 15 meter. It's higher than the graph. So we will have two velocity for this one. First one is that when it goes up, that is 5.5 meters per second. The other one will be it goes down. That will be negative 5.5 meters per second. So make sure that you have two answers here. Don't just take the square root of it and just keep the positive one. You must think more based on the situation is given. We have two times that it reach 50 meters above the point of projection. So you must notice it. And now for part B, it's a little bit tricky. This time it goes down and repeat to hit the ground. This time you will see at the very beginning, I don't care. I do not care the roll when we throw it up and go down. I only care something about that when it go back to 4 meters and it go to and finally it hit the ground. We only can see that this negative 4 meters for S. So we choose negative 4 here. Secondly, once again, the gravity, negative 9.8 meters per square second. Thirdly, we have U and V. And this time, U, once again, is 18 meters per second. And the speed, I'm going to find V again. So I do not have T. So once again, V squared minus U squared is equal to 2ax is used. So we will have V squared minus 18 squared is equal to 2 times negative 9.8 times negative 4. So the answer of this one is V is equal to plus V squared is equal to 402.4. And please pay attention about it. This time when you take square root, because we know that the final result it will hit the ground, so that means that will be the velocity, which is negative. So this time I will only keep the negative sign of it, negative square root 402.4. So this is negative 20 meters per second. That means I will go down, it goes down and with that with the negative 20 meters per second. So don't keep the positive one for the question 5. Okay, now we will go to question 7. So first of all, if you cannot finish these two questions, you have any problem, you can pause the video and you can go to the live conference so that I will be there so that you can ask me any question about this one. Okay, now we'll go to question 7. Okay, let us look at the question. Once again, first of all, a particle P is projected vertical outward from a point X. 5 seconds later, P is moving downward with speed 10 meters per second. For A, find the speed of the projection of P. That means what is the starting velocity? That means something that, what is that? Okay, let us think. For part B, find the greatest height above X attempted by P during its motion. Okay, let's also find it. Okay, now please pause the video and try to find out that, draw the figure and diagram and also find out that what is the U, V, A, S, T in these questions. Okay, now we come back to the question. So if you do not finish, just pause it now. Okay. Now for part A, you will see. I'm going to find the speed of the projection of P. That means U is not given. We want to find out the answer of U. And obviously for A, okay, first of all, we must take upward as a positive direction. Every time, write it down first. Second one, we know that for the seventh of the questions, we know that 5 seconds later, P is moving downward. That means time is 5. I do not know that it reached the highest point or not. But we know that for the time with the 5 seconds, V is negative 10 meters per second. So that means I think it almost finished. To reach the top, and then we go down. So for A, we know that this time is negative 9.8 meters per square second. Okay. So this time we do not have S. We are going to find U. So that means this time we have V is equal to U plus AT to solve the problem. This time is negative 10, which is equal to U plus negative 9.8 times 5. So you will see at the very beginning, U is equal to 39 meters per second, which is the initial velocity for part A. If you do not finish B, okay, you can proceed now. Okay, if you finish it, okay, now we will have part B. Part B. Once again, U, V, A, S, T. This time I'm going to find the greatest height above X attempted by P during its motion. So that means I really want to find out what is S. And from the 7A, we know that U is equal to 39 meters per second. So we write it down. Because we know that when the particle reaches the highest point, it will change the velocity from positive to negative because it will go down. That means the velocity at that moment will be 0 and x minus 1. And then obviously we know that A is negative 9.8 meters per square second again. So I do not have T this time. Maybe you say that T may be 5 seconds. I'm sorry about that. T is not 5 seconds in this question because we will look at the question carefully. The question say that 5 seconds later, P is moving downward with speed 10 meters per second. The speed at that moment is not 0 because we must make sure that at the highest one, the velocity is 0, not negative number 10 meters per second. That means I think that the time will be a little bit faster than 5 seconds and it reached the highest point. So this time we cannot use T to do this question. So we have U, we have V, we have A, we have S. So we will use V squared minus U squared, which is equal to 2AS. So we plug in the numbers 0 squared minus 39 squared is equal to 2 times negative 9.8 times S. So the answer of this one, S is equal to 78 meters. So that means the greatest height above X attempted by P during its motion is 78 meters. Okay, now we will go to the last question we want to discuss with you. That is question 9. So if you cannot finish now, so just pause the video. If not, you can continue this reading now. Question 9. A stone is rolled vertically upward from a point which is 3 meters above the ground, with speed 16 meters per second. Its motion as modeled as that of a particle move freely under gravity. Sketch a speed time graph. This time, I want a speed time graph of the motion of the stone from the time it's projected to the time it hits the ground. Show clearly the time at which the stone is instantly stationary. That means the maximum point. The total time of flight and also the speed of the stone when it hits the ground. So that means, first of all, you need to draw the diagram. And then you must point out what information we need to find before we draw this ST graph. Okay, now please think something and also draw the diagram first, and I'll teach you how to do this question later. Okay, now we will start to have a discussion on it. So if you want to do something, you can pause the video first. Okay, we now have it. First of all, let us draw the diagram. A stone is 3 meters above the ground. It's thrown vertically upward. And the initial velocity, 16 meters per second. And then it goes down. And then we know that finally it will hit the ground. From the top, the highest point, the maximum height of it. So first of all, obviously you know that from the question that we done before, we know that it was starting from 60 meters per second, and it will go to the 0 meter per second, because we know that for the stone, when it reached the maximum height, the velocity of that time is 0 meter per second. So that means what we need to find is that what is the time it lit here? Because I'm going to draw the speed time graph, so I must make sure that I got the time t there. Secondly, for the second one, after you going to down to hit the ground, you must know the two things. First of all, you must know the velocity of it, and also we must know the t. That means we do not have velocity at the last moment, and we do not have the t of it. So we need to make sure that we got A, S, and U for these three situations. Okay, now, first of all, I want you to find out the t first, for the when it reached the highest point. So if you are now going to do, please pause the video now. Okay, now we will continue our topic. Now, first of all, I want to find the time t, okay, when it reached the maximum height. First of all, we will have the u is equal to 6 meters per second. We have v is equal to 0 meters per second. And we know that the a this time is negative 9.8 meters per square second. And we are going to find the t. So that means we must use v is equal to u plus at. But first of all, you must take upward as the positive direction. So we will plug in the number 0 is equal to 16 plus negative 9.8 times t. So we know that t is equal to 16 over 9.8. That is 1.6 seconds. So that means when it reached the highest point, the stone needs 1.6 seconds. So we can at least draw the graph like this first. We have the almost first part of it. This is the time, this is the s. From the 0 times 0, the velocity is 16 meters per second. And after 1.6 seconds, we know that this one is a straight line because this one is a constant deceleration. That means it will go down from 16 to 0 with 1.6 seconds. So this one is a straight line. So we draw the first part of it. And the second part of it, we need to find V and also T based on when it hits the ground. So the second part we need this time is that for the situation we have is we use blue pen to draw it. U this time I can still continue to use 6 meters per second here. We just consider this part of it. And the S is -3 meters. We go down for it. And the gravity is once again -9.8 meters per square second. Okay, so we will use these three information to find out T and V at the same time. So first of all, we will use the S is equal to UT plus 1/2AT squared to find out the time at the last moment. And also, we will find out that V squared minus U squared is equal to 2AS. Okay, I use another color to find out the velocity, the final velocity when it hits the ground. So first of all, let's plug in the number first. We have -3 for S. U is 16T plus 1/2 -9.8 T squared. That means we have -3 is equal to 16T minus 4.9 T squared. So we can make it as a quadratic equation, 4.9 T squared minus 16T minus 3 is equal to 0. By using the quadratic formula, we see that T is equal to 3.4 seconds. And for the other number, you know that that one will be negative. So I will not consider it as an answer. So we have T is equal to 3.4 seconds. And the next one I want to find out is that the V, the velocity of here, okay, we use V squared minus U squared. So V squared minus 16 squared equals to 2 times -9.8. And also the S is, this time is -3. So we will find that V squared is equal to 314.8. And then so V is equal to -17.7 meters per second. Make sure that it goes down. So that must be negative. Oh, so that means we have all the information and I can draw this diagram. Now, look at this one. We will draw it now. First of all, once again, we have the ST graph. T S0. We have 2 times. First one, 1.6 seconds. The second time is 3.4 seconds. And for S, first of all, I have a time is 16 meters per second. And we have another one that is the final velocity is 17.7 meters per second.